Good afternoon, all. My name's Bob Harris. I'm Technical Director at AEC. I'd like to welcome you all to the latest of AEC's technical webinars. The subject today we're going to be talking about is around the impact of COVID-19 on Legionella risk in a lot of our buildings, really. We're going to be focusing on hot and cold water systems, which probably the vast majority of the water systems. If you've got water in your offices, your places of work, toilets, bathrooms, that sort of thing, they're hot and cold water systems, and there's quite a few. Sadly, because of the pandemic, we've had to change the way that we live and the way that we occupy. And one of the sort of residual elements of this is that it has an impact on some of the risks that we face in the workplace. So water is now less widely used because there are few of us in the offices to use it. That will have an impact risk associated with our water system. So we're going to cover that. Just to remind you, we're hopefully going to take about an hour or so for the webinar. I'll be talking hopefully for about 40-45 minutes, and the remaining time will be available for questions and answers. So you can actually post your questions if you look on the right hand side in the panel. So if you send them to us, depending on how much time we have at the end of it, we will try our best to get through and to answer them all as we can. If we can't get round to all of them, there is always just follow it up possibly by email as well. Okay. So, sort of contents of the webinar. I'm going to start off with a little bit of background information. This is partly to set the scene for some of the concepts I'm going to talk about later on in terms of how we can potentially control Legionella risk. But it's also handy for maybe people who are watching who don't have a great deal of background in Legionella or understand the hazard. So I'll only be brief on that, and I'll also cover the key legal requirements again. The reason for this is not only just to set the scene for the things we're supposed to do, which are clearly documented in approved code of practice and the guidance, but it also will impact to some extent on when I talk about the attitude of the enforcement authorities in the UK as well. It's fair to say that they, like everybody else, have been affected by COVID. There is a great degree of understanding, I think, on their part, but that only goes so far, and they still have the expectation that we are going to meet our regulatory requirements, particularly where there is a foreseeable risk of harm. So we'll go on to our impression of how COVID has impacted on water systems, and it's fair to say that each of us looking in today will probably have slightly different water systems in the buildings that we occupy. There are broad categories which I will cover when I talk about the sort of the normal or the most popular types of water system we're likely to come across in our buildings. But the control options that we can apply are likely to vary. There's no one size fits all really with control measures available. And generally speaking, the more complex the buildings and the water systems you have, the more likely it will be a pick and mix approach of the various control measures available to us that will be applied in any given building. So we'll talk through those and see how it can be. And to finish off, I'll put across our direct knowledge of the enforcement authorities' attitudes as we've seen it to what they expect organisations to do by way of Legionella compliance. Okay, so very quickly, for those of you who've not dealt with AEC before, just to let you know who's talking to you, we're a health, safety and environmental consultancy. We've been in operation for about 23, 24 years now. Legionella risk assessment and water hygiene is a big part of what we do. We're about 100 consultants around the UK and world. Our key services are apart from water, are asbestos, consultancy, health and safety, occupational hygiene, fire safety. And we're one of the largest vocational trainers for the BOHS in the UK, where we train people, for example, on Legionella related P900 series courses. Okay, so let's look at the background to the current issues. Legionnaire's disease was unheard of until 1976, when there was an American Legion convention in Philadelphia, a large hotel where about 2,000 former veterans in the American Legion turned up to celebrate the anniversary of the signing of the Declaration of Independence. They had a really good time by all accounts, and but when they all went their separate ways, within a few days, some of them were coming down with really aggressive pneumonia-like illness. It took them best part of a year to find out what was causing this, and in the intervening time, over about 220 people came down with this particular disease. 34 of them ended up dying. They didn't know what the cause was, but they knew it was from the convention centre in Philadelphia, and they eventually tied it down to a previously unknown bacteria originating in the air conditioning system that was spread to all the building. So it was a naturally occurring waterborne bacteria that was responsible. We found out that the disease is contracted by inhaling droplets of water with viable bacteria in them, and the name given to it, which has stuck with us ever since, was Legionella pneumophila, and the first variant that we found, the first serogroup, was defined as serogroup 1. So if you ever get involved in analysis results being returned to you, this very first one, Legionella pneumophila serogroup 1, is probably the most aggressive form of the bacteria, and is normally associated with most of the large outbreaks all around the Several other variants have been discovered over the years. There's over 40 species of Legionella that have been detected. Legionella pneumophila serogroup 1 is the one associated with most of the deaths and the significant outbreaks. But you can catch minor illnesses, flu, cold-like symptoms from some of the other lower serogroups. To set the scene for some of the things we're going to talk about later, I just want to refresh the temperature effects on the bacteria. We're going to rely on this for how we set our water systems up later on, but understanding the bacteria and its characteristics and what it likes and what it doesn't like is going to be fundamental for our control systems. The bacteria itself will prefer to be in the temperature range 20 to 45 degrees. During that temperature range, it will multiply, provided there is habitat and nutrients nearby to keep it going. Below 20 degrees, it won't multiply. So one of the things we can take from this is if we can keep our cold water below 20 degrees, if low levels of the bacteria enter our water systems, they won't multiply to dangerous levels. So that's one aspect we can recall. When the temperature gets to about 50 degrees, the bacteria will slowly start to die off. It may take an hour or two, but it will start to be killed, and it will be killed in a matter of minutes at temperatures of about 60 degrees or higher. So the lessons we take from that, from our water systems, is for our hot water, we definitely don't want it to be in the range of 20 to 45 degrees. We want it to be at least 50. And if we're going to store volumes of water, we want to store it at 60 degrees centigrade. So this thermal control method is the main Legionella control method we apply in the UK and worldwide, really. So I'll be referring to this as we go through the controls later on. So why has it become a problem? Legionella is an issue because over the last 100, 150 years, we've started to bring water into our buildings, and we've changed the way that we use that water as well. So showers in the last 60, 70 years have become more common. So as a consequence of us bringing water into relatively warm buildings, or storing the water in large containers like tanks and cylinders, we now have the potentially right combination of warmth, nutrition, which can be provided by organic materials or simple things like rust that may enter our system, the sediment that may build up, the microbiological organic slime, which we refer to as biofilm, that can form in our systems. It also provides shelter and nice stagnant conditions which the bacteria prefers. We tend to think of the bacteria as being waterborne and floating around, but most of the bacteria in any system, if it's colonized, will be adhering to the biofilms, to the sides of the water containers, in nooks and crannies. Only a smaller proportion will be free flowing and going through the system. So it needs that shelter. And for us to catch the disease, we obviously need to have some form of aerosol being created. Probably the most significant risk in hot and cold water systems is going to be showers, because that is designed to create an aerosol, and it's right in the breathing zone of individuals who are taking the shower. So people are there to contract it, some of whom are much more susceptible to contracting the disease than others. The at-risk groups include certainly those with weakened immune systems. So, for example, patients in cancer wards on hospitals where their immune system is being suppressed to cope with the treatments that they're receiving, they would not have the ability to fight off an infection. So they're specifically at risk. The elderly, people who smoke too much, drink too much, again, this inhibits their defense mechanisms. And statistically, males over 50 are often 2 to 3 times more susceptible than the females of the same age as well. So there are a fair proportion of the population that is, particularly at risk of contracting the disease. So in terms of where Legionella could be, because it's potentially present, albeit in extremely low levels, potentially in the incoming main supply into any particular building, anywhere where we keep water, where the water could be in the range for growth for the bacteria, where there are nutrients, it could be in any of them. So all of those systems you can see could potentially be inoculated, and we need to consider them and assess them. But the highest risk water systems tend to be industrial cooling systems like cooling towers and evaporative condensers. But coming up behind those would be building hot and cold water systems, which we're going to sort through today. But you can see it could be in sprinkler systems, vehicle washers, industrial scrubbers, a number of different miscellaneous processes. So in terms of what the law demands, I think it's fair to say that since COVID hit, I don't know if you recall back at the end of March when much of the British economy fell off the edge of a cliff, a lot of organisations were faced with a bit of a dilemma. They had commercial reality that they had to cope with. They had to protect the businesses. They had to look after their people, maybe send them home. Their suppliers perhaps were closed down and couldn't meet their commitments. So the sort of balancing act of commercial commitments and compliance obligations was a significant issue for many organisations at that time. And as I say, the enforcing authorities did say that they would be flexible. To some extent, they appreciate the pressures on businesses, but that only goes so far. And as we've returned to an element of partial normality, which is again in a state of flux, that expectation is that we are certainly able to undertake more of those compliance obligations. So, but where there is a foreseeable risk, And with Legionella, there is a foreseeable risk, because we do know that buildings have changed in use, the risk has been enhanced. The enforcing authorities will be expecting to see us do something about that risk. So a bit quick backdrop to legislation in the UK, safety legislation. At the top of the hill is the Act, the Health and Safety at Work Act. Places general duties on employers and employees just to ensure the safety of our employees and others as it might be affected by our undertaking. If we're in control of premises, we should provide safe premises. We as individuals, Section 7, should be ensuring our own health and safety, not put anybody else at risk as a consequence of our actions, follow safe working procedures, etc. So you can read that from cover to cover. Doesn't mention Legionella once in there. It starts to be mentioned really in the regulation layer beneath. The key regulations applying to Legionella are the COSH regulations, Control of Substances Hazardous to Health regs. You may think that's just chemicals and exposure to dusts and vapours, but that also includes microbiological agents, so bacteria like Legionella fall under the COSH regs, as well as, and forgive the jargon, the Management of Health and Safety at Work regulations. These are the umbrella risk assessment regulations in the UK that require us to risk assess every task that we ask somebody to undertake. Both of those are based on a risk assessment process. So we look at the hazard, we assess the risk, we put in place an appropriate control system on it, and both of them have a hierarchical approach to risk reduction. So we can't take the hazard away, we can't guarantee that the bacteria will not be in our water. We've got to assume it's going to be there, albeit potentially in extremely low levels, but it has the potential to multiply almost exponentially. So we focus on starting off with engineering controls, procedural controls, and the bit we never really get around to unless we're doing maintenance work is personal protective equipment on there as well. There are other regulations. Legionnaire's disease is a notifiable disease, so we could have RIDDOR notification requirements. And if any organisations have cooling towers, we are obliged to notify the local authority of its presence and whether it's active or whether it's been closed down or if it's been reactivated again. So there are related ones, but the two key bits of regulation that impact on how we control Legionella risk is the management regulations and COSH. Now, if you read those, they again are legal requirements, the citations, they say that the employer shall do this, but it doesn't tell you how to meet that particular regulation. That information will live in the key document for Legionella control, which is the Approved Code of Practice L8. It has a sort of special status in law because although the Approved Code of Practice in itself is not a regulation, a failure to meet an ACOP provision may be taken in law as a failure to meet the regulation to which it relates. So it's a sort of backdoor bit of regulation. So we should follow this or do something equally as good or better. And beneath that is the recommended actions, the guidance. And the key one on this is going to be HSG 274, which contains the practical day-to-day guidance on how we monitor and maintain our systems. So that will cover things like how we do temperature monitoring, how often we clean our showers, how often we inspect our cold water storage tanks, etc. Carried forward in that layer are the British standards as well. These are best management practice, but not necessarily a legal requirement. So the key legal duties, and this will impact on what we are supposed to do later on. First one is to carry out a risk assessment. The risk assessment is an extremely important part of this. I'll cover that in a second, but it spells out what we've got and gives us guidance on what we can do to minimise risk and control it. When the risk assessment is completed, it gives us enough information on which to prepare what we call either a control scheme or a written scheme. In effect, this is like an operations manual for the water systems that you've got, and it can be on a couple of pages of A4 if it's a simple one. It can be on 80 pages if it's a very complex one, such as industrial cooling systems. But either way, we should understand the parameters for normal and safe operation of our water. We would then normally have the problem of implementing these control schemes on there, often appointing a competent person, and the regulations call it the appointed competent person or a responsible person to make sure that these things happen. Anything we do, we're supposed to record, and as common with all other safety regulations in the UK, we're supposed to check that the system is working and that the controls are effective. So there's an annual review cycle on our procedures that we're going to adopt as well. Training is also a requirement, so if people are given tasks as part of a Legionella management system, they should obviously be competent to undertake those tasks. So the risk assessment, if any of you watching are involved in compliance, it's the equivalent of your asbestos survey or your fire risk assessment. So without it, you don't know what you've got, whether it's effective, whether it's configured correctly, whether it's in control or out of control. So the risk assessment is the foundation of your management system. So at the end of it, it will tell you, probably provide a great big long shopping list of things that need to be done, which may include physical repairs, alterations to the water systems because they're incorrectly built, but it will also give you that long-term list of checks, tests, inspections and maintenance that need to be applied to keep the water system in control. The actual risk assessment document itself, and I'll come on to this later on in the talk, is subject to a review cycle itself. It's not the same as your procedures review. This is the actual risk assessment document itself. It's meant to stay current and accurate. So if conditions change, it should be reviewed, and if there is no significant change, it should be reviewed. The word is regularly. The HSE guidance in the approved code of practice used to be every 2 years, but that was replaced with regularly, so that there was a degree of flexibility for businesses to do this work related to the risk of the system itself. So if you have a relatively low risk system, a very simple one, it might be every 3, possibly 4 years. If you have a high risk system, it gives us the flexibility to do it perhaps every 12 months, a bit more frequently. So we can adjust that slightly, but the element I'm going to discuss later is the fact that perhaps we have had a significant change in the use of our water systems, and that may make us think about a review or a reassessment. So again, going back to things that the bacteria like, the methods we apply to control Legionella risk normally involves denying the bacteria the things it needs to survive and multiply. So we keep our water systems clean, and by doing that we take away the sources of nutrition, the sediments, the bio buildup, as well as the habitat that the bacteria likes to live in. So so periodic cleaning, making sure we do our inspections to ensure that the system stays clean, is one of them. We keep our hot and cold waters in the temperature ranges that prevent it from multiplying, and ideally in the hot water situation we'll kill it off relatively quickly if the bacteria should penetrate into our water systems. We try to avoid stagnant conditions because, and I'll cover stagnation in more detail in a second. Stagnation allows water to stand. It allows, therefore, the water to potentially acquire room temperature. So there's a number of different things that, and as the temperature goes up, the multiplication of the bacteria may continue. So by avoiding stagnation, by making sure the water is used and refreshed with clean water all the time, again, we keep the bacterial levels low. If we can't keep our systems clean by these sort of means. Normally we will do something else, and there are a range of other treatments for the water, be it thermal, be it chemical, or it can be ultraviolet light, or by adding metal ions. There's a number of different ways we can do it, but we can add additional safeguards that could potentially control if we can't do it by standard means. So if we create a management system, if we start looking at how we're going to control our water, that long list in front of you, it's normally a combination of these. So temperature monitoring and control is the standard approach in the UK. It's relatively easy to do, it's cheap, it's easy to test. So consequently, it's the HSE's recommended approach. In some cases, if we've got stagnation in all or parts of our supply, we can activate the outlets, which in English is turning the taps on. So we allow water to run out to be replaced by fresh water. We can clean and disinfect. We can do that to shower heads, we can do it to tanks and hot water cylinders. And we have a series of checks and inspections. So we're looking inside our cold water storage tanks, for example. We may purge the water from the base of our hot water cylinders till it runs clear and gets rid of some of the sludge that built up in there. We can chemically treat. We can make physical repairs and modifications. Training of staff is part of the system as well. In certain cases, we may need to take water samples, and this again normally is not recommended, but at times like this where our systems may be edging a little bit out of normal control, water sampling may form part of your control scheme as a degree of reassurance, possibly everything's still okay. But in certain circumstances, like in cancer wards in hospitals, that is part of the day-to-day regime because they cannot afford to take the risk and they need that added reassurance from the water sampling as well. So all of those elements fit into how we control our water. So just to give you a rough idea, having talked through the risk phases and the sort of things that can be a problem, I'll just give you a very quick overview of the main types of hot water systems that we have in our buildings. You'll hear me refer to hot and cold water as domestic hot and cold water systems. It's common terminology, but effectively what it means, it's not just houses. These water systems we have in our offices are often just bigger versions of what we have at home. So I'll go through and I'll talk about mains fed direct heated systems, similar to our Combi boiler type systems at home. Gravity fed ones, which are tanks and cylinders, again, which many of us still have at home as well. But it will also, this process will also apply to all the other water systems we may have in our workplaces, including industrial process type water systems. Okay, so the image you can see on the screen now is what we call a traditional gravity fed hot and cold water system. This was being installed in houses for decades before we started to adopt the most common modern day mains fed instant water heating systems, which I'll come on to in a second. But just to highlight how risk can vary a little bit in a water system, mains water will be coming into our buildings. The mains in the UK is incredibly clean, but it's not 100% guarantee to be clean. There may well be very low levels of bacteria in there, including potentially the Legionella bacteria. And if it gets into our systems and the conditions are right, one bacteria can turn into 2, can turn into 4, can turn into 8, and so on. And the numbers can increase exponentially if the conditions are right. So in the mains water, it's relatively clean, and normally, traditionally, the mains water fed 2 outlets. One would be the drinking water taps in our kitchens typically, and would go on then to supply the cold water storage tank, normally located high up in the building, normally in the loft, where it would build up a supply that could go and serve typically the non-drinking outlets, which were the bathroom, cold water taps and toilets, possibly mixing with the hot water for mixer showers on there as well. The other element that it fed was the gravity would allow it to feed the hot water cylinder in the property. So that cold water would come in, typically at low level, and most cylinders are what we call indirectly heated. So if you look at that coil that's inside the hot water cylinder, water from a boiler would typically come in there. That pipe would be very hot, and the hot pipe would heat the water surrounding it. And going back to the laws of thermodynamics, hot water rises, and we would always draw off our hot water supply for our taps from the top of the cylinder to go to our hot taps in the bathrooms and kitchens, etc. That being said, if we think about the risk of this kind of system, when the water enters the cold water storage tank at the top, there is the potential for it to stay there for a period of time. Now, the general wisdom is that we only try and keep 24 hours worth of supply of cold water stored in our buildings, because we want it to be replaced with fresh water all the time, because that keeps the bacterial levels down. But if we can't do that, that water may be present in there for several days. And what will happen is that because the water is not moving, the bacteria may latch onto surfaces, they may be caught in biofilms, and the numbers can grow. So one of the first risk phases for our water system is the potential growth of bacteria in the cold water storage tanks. Bear in mind, in the summer, this could be in a loft, and they can get quite warm as well. And if it's not insulated, the temperature levels can increase, and a consequent increase in the bacterial levels will follow on. Now that then enables us to filter this down and actually provide potentially contaminated water into the hot water cylinder at the bottom. Now, the reason we've got color coding going on the cylinder, the hot water is always hottest at the top. We try to get 60 degrees up there, so it will kill any bacteria off pretty quickly. But depending on the nature and size and how tall a calorifier is, it's not inconceivable that the temperature at the base of one of these could be around 40 degrees. And it could well be a potential habitat where bacterial levels can grow significantly as well. So by storing hot water, we introduce a risk element. So we've got to be very careful about the temperatures at which we provide water from the cylinder, and the temperature it reaches the outlets, like the basins in our bathrooms as well. Okay, so there are critical points on our water systems where that risk can magnify. One of the things I'll be talking to you about when I go on to stagnation, just briefly to illustrate it on this this diagram. If you can imagine this area, say this is one particular bathroom here, and for whatever reason we don't use the basin and the toilet in that one for any period of time. The pipework that comes through to serve these outlets will effectively lie stagnant. The water inside it will stay where it is, and the water will acquire room temperature. So if it's in a building, that may be 23 degrees, 24 degrees, depending on how you've set your thermostats. But this is what we refer to as a dead leg. And later on, when I talk about water treatment and possibly cleaning and disinfecting water systems, dead legs like this can compromise your ability to clean your water systems properly. So for example, if this was to be left for any length of time, if bacterial levels grow, and we either disinfect the main runs of pipework, the disinfectant won't enter very far down into these runs of pipe. So we could take samples at the outlets after we've cleaned it, that'll look fine, but the bacterial levels that may still be present in these dead legs could find their way back into the live system. So dead legs, which are outlets that we can open but we don't for whatever reason, or blind ends, which are lengths of pipe which are permanently blocked off, so it's a static slug of water, they can cause us problems later on if we do get around to doing clean and disinfect or thermal pasteurisation of the hot systems, which I'll elaborate on in a second. So, two major risk phases due to the storage of water on these traditional gravity-fed systems. The more modern approach to bringing water into our buildings is to have mains-fed, instantly heated water supplies. So this is a typical domestic Combi boiler type system. The mains comes in and will supply the taps throughout the building. So your bathroom would normally have main supply as well as your kitchen. And if we need hot water, then on demand, the mains water transfers through a heat exchanger inside the boiler and goes straight out through the tap. So we've taken away the water storage element and therefore the element of stagnation, which is a big part of the reason for risk growing. So by using these kind of systems, we greatly reduce the inherent risk from Legionella colonization in the system. Just very briefly, I was asked a while back, the central heating systems that are fed from these systems, they are a closed system. There's no aerosol generation. It's not connected directly to the tap outlets. So the risk associated with these central heating systems is incredibly low. It only becomes an issue potentially if there's a significant maintenance task going on where there's an aerosol likely to be produced. Okay, so considering the impact of COVID, what has that led to? I think it's probably a safe bet that many of you listening today are joining us from home on your laptop, because the government advice is that we work at home if we possibly can. And as a consequence, the sort of occupancy levels inside many of our workplaces is a fraction of what it was before COVID arrived. Many organisations, certainly some that we've dealt with, have closed their buildings. So effectively, at the start of April, they put a padlock on the front door and just walked away. So the water systems have been effectively stagnant for months in that regard. So there is no way that that has not had an effect on the potential for bacterial growth and therefore an increase in the risk from Legionella. So the sort of scenarios we've come across, some buildings are closed and the water is not used, so they've actually ceased occupancy. Nobody's been going in to carry on with any of the maintenance aspects. Some buildings have been closed, but somebody's popping in to keep a bit of a lid on it, maybe flushing the water systems occasionally, that sort of thing. Some buildings have remained in operation, and this is what we've seen the most of, but with reduced staffing levels. Some have gone the other way. Sadly, the GMX in Manchester has been converted into one of the Nightingale hospitals, and I believe that is now starting to take patients in there now, the COVID patients. So that is a totally different use for the water. But a small but significant proportion have carried on business as usual. So some businesses have not been affected significantly, and therefore their current precautions, procedures and risk assessments are still perfectly valid. The main problem associated with reduced use of buildings is the reduced use of water, and the fact that that water is now no longer coming out of the taps or through the toilets and is staying in the storage and supply pipework systems longer. So it's stagnation. The image you can see on the right of the screen is surface scum, and that's caused by stagnation and the fact that no fresh water is breaking the surface of the stored water there. As I mentioned earlier on, the general advice is that we store no more than 24 hours supply. But if you think of, you know, if you had 100 people in your building and that's now down to 25, they're probably only using 25% of the water. And therefore, what used to be a 24-hour supply is now 4 days worth of storage. So that will have an impact on relative stagnation. If we have stagnation in our systems, it allows the water to remain static, so stay where it is in the cylinders, tanks, and pipework, and that will enable the bacteria present to stay there longer, to multiply longer, and therefore to multiply to more significant numbers. The water systems, regardless of how well they are insulated, will gradually acquire room temperature under stagnant conditions. So you know, the influx of fresh, clean water at 9 or 10 degrees will not have that effect and keep it cool. It's going to be acquiring the ambient room temperature sooner or later as well. So that may get to a level where bacterial multiplication could start. If it's stagnant pipework, we've talked about it potentially providing a little reservoir where bacteria can grow and go back and seed active parts of the water system. And it will also allow the growth of biofilms. This is one of the most significant sort of growth areas for bacteria. It's like a transparent slime, which we often find around the edge of tanks, but could be present inside shower heads and supply pipework as well. And that in itself is a little microcosm with plentiful nutrition for bacterial growth as well. So a lot there that can give us problems. So in terms of the risk reduction, basically buildings and the water systems are likely to significantly alter. You've seen some of the simple systems, but if you go into a larger building, you can modify that with pumped supplies, potable water storage tanks, different types of heating system, local point of use, plate heat exchangers. So there are going to be lots of different variations, and therefore there are going to be several options available according to the type of water system that you've got. So the typical range of risk reduction measures that people consider as part and parcel of a maintenance system like this. First of all, if it's a simple water system, you may be able to get by simply flushing the water through. Something like your Combi boiler system at home, where it's fresh mains water just coming through, minimal storage capacity in there. But if you've got larger water systems with tanks and cylinders, flushing is still an important part of it, part of the method of control, but there's larger quantities that need to be flushed through as well. So that might be you know, a fair old time of flushing, and you may want to consider that you flush it and what kind of temperatures they're flushing out at as well. So you've got high ambient temperatures, you'll have elevated temperatures in the water storage. You might want to run that through so you've got temperatures below 20 coming out. We may increase the temperature of the entire system above 60 degrees to try and kill off any bacteria in the hot supply. It's called pasteurisation. And we should still be checking the outlet temperatures to make sure that we can deliver temperatures in the right range for us. Other measures could include chemical treatment of the water systems, as well as mechanical alterations. I'll cover these very briefly in a second. Water testing, water sampling for bacteriological levels is also something we should consider. In some buildings like hospitals, it's more or less a given. In other ones, it tends to be not necessarily mandatory, but it might be a reassurance issue that we should consider. Certainly if we can't ensure control by other means. So outlet flushing is likely to be an ongoing requirement. So if you've got less people in buildings, if you can't change the storage capacity, you want to get rid of some of this water to make sure it's replaced and refreshed. So outlets that may have been in regular use are no longer in use, so you should identify them. You could be isolating entire parts of your building by doing this, and what you don't want is part of your supply to effectively be a great big dead leg to potentially recontaminate the rest of your active supply. The loos, toilets, bear in mind if you're going to flush, you should actually flush the toilets as well. They tend to use more water than the basins, so it's not just taps we need to think about on there. And if we do have tap outlets fed through TMVs, thermostatic mixer valves, then remember that's a merged hot and cold water supply. So when we activate a tap, 5 minutes, it's probably only 2.5 minutes of flushing time for each of the hot and the cold pipes that supply it. So we may have to do a little bit more in those. But keep an eye, particularly on your cold supplies, and try and make sure that they are below 20 degrees when you flush. Cleaning and disinfection is most likely to be required on the larger systems or systems where you have storage, so tanks and cylinders. Certainly, the likelihood will increase if there's a risk of aerosol generation, and definitely where there is a susceptible population. If you leave your system out of maintenance for any length of time, beyond several weeks, with no significant controls in place or flushing, it's certain, I would say, that you would need to consider some form of clean and disinfection of the entire system before you can reoccupy. Biocidal treatments, these are the ones that we use to disinfect. Typically, most of them are chlorine based, either from sodium hypochlorite or bleach, or chlorine dioxide, although there are other proprietary products we can use as well. This typically requires us to get to a certain level of chlorine. It's normally 50 parts per million, and we would put that through the tank and run it through all the tap outlets and measure the chlorine concentration at all the outlets, and when it's gone through everywhere, we seal it all off, leave it to stand, and hopefully the chlorine will do its job and kill off any bacteria in the system. That's the normal way that a system would be disinfected. The other thing, I put the final one, consult your Legionella risk assessment and your schematic drawings. The presence of dead legs or blind ends in your system can compromise this. It may come through all the tap outlets you get to, but if there are dead legs present, they won't be thoroughly disinfected, and they need to be either cut away or opened up as part of the cleaning process. Thermal disinfection, this is raising the entire cylinder up to levels above 60 and all the way through to the outlets. If we can get faith that's happened, then we can thermally disinfect the hot water system in its entirety. It's a temporary measure. We don't want to leave scald hazards behind, but you want to keep people away from using the hot tap until this pasteurisation process is finished as well. Again, dead legs will have an impact. Mechanical changes. In certain instances, we've seen perhaps if you've got multiple cold water storage tanks, if your usage is dropped, then why not isolate one or more of those? Reduce your storage capacity. You can isolate parts of buildings. You can actually use some of the automatic flushing devices. So, for example, in the gents' toilets, the urinals often have a sensor that flushes at a set frequency that can be changed. And I've seen organisations who, in effect, put in temporary main supplies for the duration. So the usage has dropped so much, it's not worth keeping the old system in operation. So they just keep one part of the building with a separate water supply, knowing that they are going to have to do something to the rest of the water supply when they return to normal occupancy conditions. So water sampling, as I've said, is not normally something we would advise, but it may well provide you a degree of reassurance that the systems are under control. If you do carry these out, you should send them to your UCAS laboratory for analysis on them as well. So most large water systems are likely to need a combination of those various measures that we've just gone through. And in order to do that, you've got to, for it to be a reasonable action plan, you've got to have a good idea of what your new normal occupancy is going to be, and that can be very, very difficult to predict. But it may well be that that's what excites a review or a new Legionella risk assessment for your building. That should give you a revised action plan, a new maintenance regime. And one thing to remember is if you do go through this, if you clean and disinfect and make safe your water systems, you've got to put the control scheme in place after that, because the danger is that you clean it all up, but it falls out of control again because you're only doing half the control measures. in which case you may have to go through the whole rigmarole again. But if you do these sort of bring you up to speed, getting things ready, getting things under control, if you use things like chemicals for treatment, if you use pasteurisation, you will be adding potential cost implications and potential physical safety issues during the cleaning and pasteurisation processes. Part of the regulations, the management regulations, is that employers should have access to specialist advice. If you've got very complex water systems, you may have in-house capability to respond, but you may have to bring in somebody from outside to advise on these sort of things. So I think on more complex site, that bringing in the advice is probably a necessity for an appropriate action plan to put in place. Each site's likely to vary a little bit, so some form of bespoke response is going to be required. And if you do get somebody in to advise you on that one, obviously make sure you've got somebody who understands your kind of water systems and knows what they're talking about. Just some quick ones to finish off with. If you do any of this, we are obliged by law to retain records of all the things we do. Your Legionella records, because we are often monitoring transitory conditions, it is your only proof of what you've done. So your temperature monitoring records, the fact that you cleaned a shower head on a quarterly basis. So you should keep those documented along with all the other related documentation like risk assessment reports. The other thing is it can be electronic, it can be paper-based. A written paper logbook is absolutely fine, but you're supposed to keep those records for at least 5 years. In terms of the enforcement authorities' attitude, we've met with HSE and several local authority EHOs. Both of them believe that the Legionella risk during lockdown and the changes to it are foreseeable and therefore can be reacted to. So I don't think they would take any excuses for not doing anything about this. It is foreseeable that change in water use will lead to stagnation, and therefore we need to counteract the effects of that. So reasonable steps, I think, would be expected to have been put in place. Just to pass you on to some areas for further advice if you wish to go there, and this I think we will be able to post for you to look at and download. But basically, I've put in there the links to the HSE's advice on buildings during COVID. CIEH, the professional body for environmental health officers, have published their own advice, and the LCA, the Legionella Control Association, also give advice on what to do and how to do it. I think we're all singing off the same hymn sheet, so if you read through there, they won't be too dissimilar from what I've talked to you about this afternoon. And so to summarise, COVID has led to a change in the way we use our buildings and our water systems, and the general reduction in occupancy has led to a reduction in water use, and this can lead to stagnation. So there is a real potential risk in our water systems unless we react and adapt to the changing circumstances. The enforcement authorities do expect us to identify and put some measures in place to counteract this, and because there is a major change in the way we use our buildings, it may excite a review or a reassessment of Legionella risk at the sites. Your action plans are likely to vary with the design of the water system, so there is no one size fits all. It may well be a pick and mix of all those different measures that I've tried to explain this afternoon, and you may need to bring somebody in to advise you as to an appropriate way to counteract the risk in your particular water systems. If your system has fallen out of control, so if you've left it for a while and you're about to reoccupy, it's likely to require major remedial works on it, by which I mean probably a clean and disinfection of the system itself. And please remember to record everything you do. Keep those records of clean and disinfects, because that's your proof that you've taken the reasonable steps to sort it out. And you'll be pleased to know that's the end of the spoken part of the webinar. So hopefully that's been of use. Explained a few reasons why we do it and the sort of options that are available to you. But I'm happy to take questions on this, and if you bear with me, I will endeavour to read some of these and go through them. Okay. Right. Hi Bob, I have several offices that are closed. Should I be taking monthly temps, or can I leave it till it's open again? Simple answer is, if you've closed the system, closed the building, and you've got significant storage capacity on there, if it's been left for several months, you're going to have to go in and do something major to it to bring it back into safe operation again. So taking temperatures will give you a degree of faith that you might have sort of temperatures outside the range, but the stagnation problem is unlikely to have changed. So the likelihood is, whether you take the temperature or not, you're going to have, when you reoccupy, when people go back in, you're going to have to do something to make the water system safe in there. So there's going to be work to be done anyway in that regard. Might be a little bit, might vary a little bit if it's very simple, basic mains type systems, but the more likely answer is, if you've got storage in there, you're going to have to do a major clean of the systems before you reoccupy, I would say. Second one, is it considered a requirement that the responsible person has managerial and budget responsibility within the organisation, or can this be delegated? The responsible person, or the HSE made a bit of a mistake when they put this wording out. Every other set of safety regulations calls the person who's got day-to-day responsibility for implementing the controls as the responsible person. Under water, under the L8 ACOP, it's the appointed competent person. But yeah, that person who's got the day-to-day job doesn't necessarily have to have the budget, but they should have the resources. Even if the budget's decided by somebody else, they should be able to demand the resources to do the job properly. The general approach is they should have the authority to be able to implement the actions that are necessary, and that can be delegated from somebody else. So they don't have to be in total control of money or a line manager in that regard, but they would need very close support from the people who can provide that. Is it worthwhile taking more water samples as the building is only half full? The answer to that one is it may be. The water samples can give you additional reassurance that the system is still not inoculated by the Legionella bacteria. But there are other things that you could do. If the building is half full, I would have thought that you might be doing things like additional flushing to keep the water turning over as well. But as I've spoken through the webinar, it depends heavily on the nature of the water systems that you've got installed in your building. But they do have the place. So at times like this, where perhaps we are at slightly increased risk, occasional monthly type water testing may well give you an added degree of reassurance, I would say. Next one, what do you recommend then for regularly if the 2 years have now been taken out of guidance? How do we know if we're safe? Okay, so this is the 2-yearly review of your risk assessments. Regularly, I would say, was introduced to give organisations a degree of flexibility, because the risks of different water systems vary dramatically. So it gave us that ability to say, well, if it's a higher risk one, I can do it annually. If it's a lower risk one, I can do it every 3 years. My guidance would always be, if you're not sure, then the 2-yearly cycle is a good one. And the HSE have gone into black and white, and that was okay a couple of years ago, so it was probably going to be okay now. What I wouldn't do is, if you've got a large and complex system, I wouldn't be dropping that down to 3 or 4 yearly. I would err on the side of caution, and if all else fails, I would stick to the 2 yearly cycle, unless you've got reason to believe it's definitely not. Okay, next one. I don't have any stored water on site, but the office isn't in use. What do I need to do? Okay, when you come back to reoccupy that, I assume it's a mains fed Combi type boiler system, which will be relatively small. It is comparable to the sort of system you may have at home. I think the key thing to do with that is thorough flushing going through the cold and the hot supply. The hot outlets, if you've got control over the temperature of the outlet coming out, I would increase that for a period of time. Make sure you've got really hot water coming through it. But if it's a larger system, it depends on how it's configured and the nature of how the water is brought together. Again, that's another one where I can give you sort of general advice, but if it is a larger system, you might need to have somebody look at that. And I suspect that might be, oh no, there's some more. With immersion heaters still present in properties with heat-only boilers, is the risk still the same as a water tank? Immersion heaters still present in properties with heat-only boilers, is the risk still the same as a water tank? The answer is yeah. So if you've got, I think you're talking about a hot water cylinder. So rather than your boiler indirectly heating it, you've got electrical elements, the immersion heaters that are heating it. That may well still be a significant risk, and I'll tell you the reason why. Most immersion heaters tend to be located on the top of the cylinder, so the heat only applies in the top third or so of the water cylinder. You'll still have temperature stratification, which means that the fresh water potentially from the tank will come in at the bottom, and you'll still have relatively low temperatures. The other thing you can do, if it's well insulated, periodically it's recommended that you heat up the entire cylinder. So if you don't draw water off, keep the immersion heater on, that heat will gradually move down, and you could end up with the entire cylinder heated above 60 degrees, which would be a good way of trying to keep the potential bacterial growth at the bottom of the cylinder under control. Because if the bottom reaches 60, it will kill off any viable bacteria in a relatively short time frame on that one. So yeah, it's still a potential risk. The heating source makes a little bit of difference, but not to the overall scheme of temperature stratification and potential stagnation. And the final one, I've reduced companies occupancy, so I've had samples taken and increased flushing, which seems to be working with regards to temps being maintained. Yeah, that's absolutely fine. So if your occupancy is reduced, what you're doing by increasing your flushing is you are mimicking normal operation of the water system. So that is exactly the sort of things we should be thinking about. And if you're taking samples to confirm that is everything's okay and hunky-dory, that's great. That's how it was meant to be used. That's giving you the reassurance that the measures that you put in place seem to be working effectively as well. Okay, so in the absence of any other questions, I will call it a day there. Hope it's been useful, and thanks for attending. And hope, if we do need any assistance, hopefully you know where we are now. Just give us a bell. We'll do our best to assist. So thank you very much and take care. Bye bye now.